So hey guys, it's me, Ivan Gio. I'm here to discuss to you what is propositional logic. But first, let us know what is the meaning of proposition. So what is a proposition? Propositions are the meanings of the statements. Meanings are the thoughts, concepts, ideas we are trying to convey through speech and writing. It is a declarative statement that is either true or false but not both. We say that the truth value of a proposition is either true or false, which corresponds to 1 or 0 in digital circuits. So these are the examples of propositions. Number 1, today is January 4, 2021. This is an example of proposition because it is a declarative sentence. We can determine its truth value as true if the date today is January 4, or it is false if today is not January 2021. The second one is please erase the board. This is not a proposition because it is not a declarative statement. It is imperative in nature and we cannot determine its truth value to be true or false. Simple and compound propositions. Simple propositions are grammatically independent expressions of information. So these are the examples of simple propositions as you can see. So for compound propositions, it is consists of two or more propositions joined by connectives such as and, or, but, and others. Propositional logic operators. Symbolizing propositions allows us to focus on the relations between propositions rather than the content of those propositions. Propositional symbols A, B, C, or furthermore, the connectives which are and, or, not, implication, biconditional, different than, exclusive or, and parenthesis. To discuss the truth table itself, I'll give you Jaeron, my friend. Take it away.
Thank you, Mr. Gio. Truth table can be used to show how these operators can combine proposition to First, negation. Negation is symbolized by this symbol and it is read as not. They can be also used to negate conjunction, disjunction, conditional, and biconditional statements. Negation of true statement is false, and the negation of false statement is true. Next, conjunction. Conjunction is symbolized by this symbol, read as and. Most commonly, conjunction are expressed as and. There are other words used to express a conjunction. Examples are but, however, nevertheless. Conjunction means that you have both or you have neither of them. Next, disjunction. Disjunction is symbolized by this symbol and read as or. Disjunction can mean you did one or the other, or you did both. Next, conditional. Conditional is symbolized by this symbol and read as if then. A conditional statement consists of two parts. The part that is in the front of the arrow is the antecedent, and the part that follows the arrow is the consequent. Next, biconditional. Biconditional is symbolized by this symbol and read as if and only if. In constructing truth table, statements and operators can be combined in any ways to form new statements. To construct a truth table for propositional logic, you have to determine the number of inputs, determine the number of combinations, and apply the rules of operators. Feel free to pause to answer this example. You got it right. So, we will now proceed to the next topic, formalizing proposition. Propositional logic is a formal language. It has three kinds of symbols, which may vary in each presentation. First, sentence letter, A, B, C to Z. We sometimes use the upper letters, P, Q, R, or even A, B, C, D. Second, operators, aka connective, with the symbol negation, conjunction, disjunction, conditional, and biconditional. Third, parentheses, used for organization purposes, similar to parentheses in algebra and arithmetic. In common use of propositional logic, sentence letter stands for complete sentences. Our interest here is to learn to symbolize natural language into propositional logic, so we will take for granted that every letter we use represents a sentence. For that note, the standard procedure is to define letters with the sentence they stand for. For example, P stands for pork is expensive. Q stands for honey is cheaper than pork. Second, when symbolizing, one should try to break each natural language sentence into an atomical sentence. An atomical sentence is one that cannot be separated into further sentences. This way, we can make use of the best level of precision propositional logic can give us. Example, my sister and I like coffee could be defined as M stands for my sister and I like coffee, but also N stands for my sister like coffee, O I like coffee. Third, we have an operation to express negation. So a negative sentence will be better expressed as positive sentence. And later, we, we can add the correct symbol. That is the atomic constituent of I don't like the bombs. D stands for I like the bomb. The sentence I don't like the bomb, but you will be a bad person if you don't understand me can be broken into A stands for I like the bomb. B stands for you will be a bad person. C stands for you understand. And last examples. Today is Monday and it is sunny day. Let P stands for today is Monday. Let Q stands for it is sunny today. Then it can be represented as P and Q. Second example, August 29, 2020 is National Heroes Day and it is holiday. Let P stands for August 29, 2016 is the National Heroes Day. Let Q stands for it is holiday. Then it can be represented as P and Q. Third example, I will pass the exam or I will fail. Let P stands for I will pass the exam. Let Q stands for I will fail. Then it can be expressed as P or Q. Fourth example, it is not the case that today is raining. Let P, today is raining. Then it can be expressed as not P or negation of P. Fifth example, if every student in this class will study hard, then many will pass. Let P stands for every student in this class will study hard. Let Q stands for many will pass. The statement can be represented by P, if P, then Q. And for the last example, to take discrete mathematics, you must have taken algebra or a course in computer engineering. Let P stands for takes discrete mathematics. Let Q take algebra. Let R take a course in computer engineering. The statement can be represented as if P, then Q, or R. Thank you.
So, to summarize, a proposition is any declarative statement that can have evaluated to either true or false. Interrogative and imperative statements are not considered propositions because they cannot take the value of true or false. So, with that, we hope you learned a valuable lesson with our discussion for today. Hope to see you soon, guys. Bye!